Welcome to video lecture on analog and digital electronics. In this session, we'll study how to design counter using SR flip-flop.
So in order to design the excitation table for SR flip-flop, first you have to write the truth table for SR flip-flop 00 input state. The previous state will be 0 1. For the input 0 1, previous state can be 0 or 1. For the input 1 0, previous state can be 0 1. Similarly, for the input 1 and 1, previous state can be 0 1. Now input is 0 0. What is the output? No change state. That is, if the previous state is 0, next state is also 0. If the previous state is 1, next state is also 1. Now if the input S and R is 0 and 1, the previous state is 0, irrespective of the previous state, next state will be 0 0. If the input for S is 1 and R equal to 0, irrespective of the previous state, the next state will be 1 and 1. If the input for S and R is 1 and 1, then it is forbidden state, or these inputs are not allowed. So the output will be don't care condition. So the output will be don't care condition. Now we have to write the output in terms of input, that is called excitation table. See the truth table for the input, for the output 0 0. What is the possible input? 0 0, or next is 0 0. S and R can be 0 or 1. Similarly, for the input output 0 1, see here we can find 0 1 here. Only one entry for 0 1, 1 0. Similarly, output 1 0. So only one entry 0 1. For the output 1 and 1, you can find two entries, that is S and R can be 0 0 or S and R can be 1 0, that I have written here. Now get the expression. So for 0 0, S and R can be 0 0 or 0 1, hence I can write it as 0x. For the output 0 and 1, S and R value is 1 0, hence directly I will write the values. For the output 1 0, input can be 0 and 1, only one entry, so I will write the S and R value directly. For the output 1 and 1, what are the possible input? Either 0 0 or 1 0. This can be combined as 1 x 0. So I have written x 0. This is the excitation table, that is 0 0 0 x 1 0 1 1 0 1 0 0 1 1 1 x 0. Now we have to design the counter. So we'll design a counter with a given sequence. Here you are not asked to design modulus 6 or mod 5 or mod 7 counter. You are given with the sequence. Sequence is given in the question. So what is the sequence given? 0 4 7 2 3 0. What is the first step? Write the state sequence diagram. State sequence diagram is 0. Next, what is the next state of 0? 4. What is the next state of 4? 7. What is the next state of 7? 2. What is the next state of 2? Is 3. What is the next state of 3? 0. So, this is the state sequence diagram. Write the values in binary. So, what is the largest number present in the given sequence? 7. What is the equivalent binary? 111. How many number of bits are there? 3. Hence we need 3 flip-flops. Now you have to write the state table or transition table. First let us write the excitation table. In order to write the state table, 0 0 0 x 0 1 1 0 1 0 0 1 1 1 x 0. Now we have to write the entries in the state table. Usually the initial entry, that is the previous state, will be always 0 0 0 1 0 1 0, that is 2, 0 double 1, 1 double 0, 1 0 1, 110 and 111. Now, what is the value for C plus B plus A plus? That is, what is the next state? So, if now we have to refer the sequence diagram to get the next state. So, what is the next state of 0? Next state of 0 is 4. So, write 4. 100. What is the next state of 001? 001 is not given in the question or in the sequence. You write don't care condition. Now, what is the next state of 010? What is the next state of 2? Next state of 2 is 3. What is the next state of 3? Next state of 3 is 0. What is the next state of 4? Is 7. What is the next state of 5? 5 is not there in the state sequence diagram. So, write don't care condition. What is the next state of 6? 6 is also not there. So, write don't care condition. What is the next state of 7? Next state of 7 is 2. So, 0, 1, 0. Now, we have to write the SC, RC, SB, RB, SA, RB. So, here CBA represent the name of flip-flop. That is, we have 3 flip-flop. First flip-flop is CBA are the 3 flip-flops. Similarly, SC and RC are the input for the C flip-flop. SB and RB is the input for B flip-flop, and SA and RA are the input for flip-flop A. Now we have to predict the value of SC and RC using the state table or transition table. So C and C plus is 0, 1. So 0, 1 means 1, 0. If the entry for C and C plus is 0, X. So whenever X comes, don't bother in the next state, write don't care condition straight away in the table. Again for 5 and 6 also it is don't care condition. No need to refer the excitation table and write. Straight away you can write don't care condition. That is, if any don't care conditions are present in the state table, then you write don't care condition everywhere in the state table. Now, if the C value is 0 and C plus value is 0, so what is the S and R value is 0, X. If the C value is 0, C plus value is 0, the entry will be 0, X. If the C value is 1 and C plus value is 1, so the S and R value will be X0. Again, C value is 1, C plus is 0. What is the SC and RC value? SC and RC value will be 0, 1. Now, similarly, we'll fill SB and RB value. So, we have to look into B and B plus value in the state table. B is 0, B plus is also 0, 0, 0 is 0x. Again, for the entry 1 and 1, entry is x0. If B is 1 and B plus is 0, the entry is 0, 1. If B is 0 and B plus is 1, the entry is 1, 0. Again, if B is 1 and B plus is also 1, the entry is x0. Now we have to write the entries for SA and RA. We have to look into A and A plus 0, 0, 0x. Again 0, 1, 1, 0, 1, 0, 0, 1, 0, 1, 1, 0. Similarly, 1, 0, 0, 1. So this I have written by referring to the excitation table of SR flip-flop. So this is the state table. After writing the state table, you have to plot the K map and you have to get the expression for SCRC, SBRB and SARA. So first we will simplify SC. So entry for SC is 1x00. So 1x00. Before that, how to plot the K map? There are three inputs C, B, A. So we have to draw three variable K map. C along the row and B and A along the column. Then you have to number the K map entries 0, 1, 2, 3, 4, 5, 7, 6. Now what are the entry for SC? Triple X 0. So triple X 0. Now you have to group it in order to simplify. You can find a quad. So what is the expression for SC? Expression for SC is C get eliminated, A get eliminated, B bar. Now we have to get the expression for RC, 0 followed by triple X, 0 followed by triple X. Next entry is 0 double X 1. So 0 double X 1. Here also you can find a quad. So what is the expression for RC? Expression for RC is, this should be R. RC is C get eliminated, A get eliminated, B remains. Now we have to get the expression for SB and RB. SB value is 0 double X 0. So 0 double X 0. So here I have done a mistake. Entry for SB is 0 x x 0. So x should come in the position 2 0. Now similarly the next entry is 1 triple x. So 1 triple x. Now you have to group it. You can find a quad. So expression for SB is C. Now you have to get the expression for RB. So RB entries are double X 0 1. So double X 0 1. Next entries are 0 double X 0 0 double X 0. So you cannot find any quad, you can find a pair. So RB is equal to C bar into A. Now get the expression for SA and RA. Expression for SA and RA. Now for entries for SA is 0x1 0. So enter the values into K map 0 x 0 1. Next entry is 0x 10 0x 10. So here enter properly. So 0x10, 0x10. So next entry is 1 double x 0, 1 double x 0. So here you cannot find any quad, you can find two pairs. Here this particular K-map has two answers. Either you can form a pair with this x, or you can form a pair with 1 and x present in the location 6. Will do this pairing. So this particular sum has two answers. So SA is equal to C into B bar plus B A bar. Now you have to get the expression for RA. RA is equal to double x 0 1 double x 0 1 and 0 double x 1 0 double x 1. Here you can find a quad. So the answer is RA is equal to A. Now RC is equal to A, SC is equal to B bar, RB is equal to C bar A, SB is equal to C, RA is equal to A, SA is equal to C A bar plus A B A bar. So here A bar is common, I can take it out. RC is, I think it's so these are the values. Now we have to, after getting the expression, we have to draw the logic diagram. We need 3 RS flip-flop, namely SA, SC, RC, SB, RB, SA, RA. The outputs are C, C bar, B, B bar and A bar. Now, so you have a common clock can be negatively edge triggered or positively edge triggered. Here I have taken it as positive edge triggered. Now, what is the expression for RA? RA is equal to A, RC is equal to A, SC is equal to B bar. Similarly, RB is equal to C bar A. So C bar A you have to get an AND gate, then SB is equal to C. Now RA is equal to A, A is equal to C A bar plus B A bar. I have implemented using AND gate and OR gate. Finally give the output to the SA. So if you are getting confused, here you can write RA, this is SC, RC, SC, RB, SB, RA, SE. If you are getting confused, you can write this. You are going to design down counter. So what are the counting sequences for mod 6 down counter? So initially it will count 5. If it is a mod 6 counter, what will be the countings? 0, 1, 2, 3, 4 and 5. 6 will not be shown. Now mod 6 down counter. Initially it will show 5. After 5 it is going to show 4. After 4 it is going to show 3. After 3 it is going to show 2, after 2, 1, after 1, 0, after 0, once again 5. These are the counting sequences for mod 6 down counter. How many number of flip-flops are required? How will you write 6? So mod 6, what is the highest counting? 5. How will you write 5 in terms of binary? 1, 0, 1. So there are 3 bits, so we need 3 flip-flops. We know the excitation table for SR, so it should be S and R. And what is the excitation table for SR flip-flop? 0, 0, 0x, 0, 1, 1, 0, 1, 0, 0, 1, 1, 1, x 0. So first we have to write the counting sequences 0. So initially the default counting sequence, so 0, 1, 2. So always in the counter design sum, in the state table, the initial previous state will be default counting sequence 0 to 8. So after 2, 3, 4, 5, 6, 7. So default counting sequences you have to write for CBA. Now in the next state, that is C plus B plus A plus, you have to refer the state sequence diagram and you have to write the entries. After 0, what is the next sequence of 0? Next sequence of 0 is 5. After 1, what is the next sequence of 1? Next sequence of 1 is 0. Next sequence of 2 is 1. Next sequence of 3 is 2. After 4, it is going to display 3. After 5, it is going to display 4. After 6, 6 will not be displayed, hence don't care condition. So understood how to design down counter. Now you have to refer to the state excitation table and you have to fill SC and RC value. Design a counter which will count from 0 to 7. So what will be the counting sequence? 0, 1, 2, 3, 4, 5, 6, 7. So up counter, so you will have an additional input called up and down. When up and down is set to 0, so you will have an additional input called up and down. So when up and down is equal to 0, the counter will count upwards, and when up and down is equal to 1, up and down is equal to 1, it will count downwards. So remember, when you are designing up and down counter in a single circuit, you will have additional input called up and down. Remember, I have done a mistake. When up and down is equal to 0, it will count downwards, and when up and down is equal to 1, it will count upwards. So when up and down is equal to 0, down counting downwards. When up and down is equal to 1, counting upwards. So what will be the state table for this? So I will write only half of the state table. The remaining part you can write. So what are the inputs? You will have an additional input called, here I will write in the short form, up and down. So you will have C, B, A as well as you will have C plus, B plus and A plus followed by the flip-flop. If you choose SR flip-flop, SR values SCRC, SBRB, SARA. If you choose D flip-flop, suppose if I am going to choose D flip-flop, then DC, DB, DA. If I am going to choose T flip-flop, TC, TB, TA. If I am going to choose JK flip-flop, JC, KC, JB, KB and JA, KA. So if I am here, I am choosing D flip-flop for the design. Now, so the possible value for up and down counter will be either it will be counting upwards or downwards. So it can, when it is counting upwards or downwards, when it is counting downwards, up and down value will be 0. So 8 zeros you have to write, 8 zeros followed by 8 ones. When up and down is 1, it will be counting upwards. Now, what is the regular sequence? Regular sequence is when it is up and down is 0, it has to count downwards, and when the up and down is 1, it should count upwards. But what is the regular counter? By default, the counter will be counting upwards and it will be counting from 0 to 7. So, 0, 1, 2, 3, 4, 5, 6, 7, and you have to write the counting once more because you have 8 entries, 8 plus 8, 16 entries, 0, 1, 2, up to 7. Now, what is C plus and B plus A plus value? So here I have told when the value is 0 for up and down, it will be counting upwards. So counting downwards. So 0, first it will count 7, 7 to 6, 6 to 5, 5 to 4, 4 to 3, 3 to 2, 1 and 1 to 0, again 0 to 7. When the up and down is 1, it will be counting 7, that is 0 to next 1. After 1 it will be counting 2. After 2 it is going to count 3. After 3 it is going to count 4. After 4 it is going to count 5. After 5 it is going to count 6. 6 after 6, 7. After 7 it's going to count 0, right? So when up and down is 0, the next counting sequence, so see here it is 0, then you have to see the first sequence. If it is 1, then you have to see the second sequence. Since up and down is 0, 0, what is the next sequence? 7. What is the next sequence of 1? 0. Next sequence of 2, 1. What is the next sequence of 3? 2. What is the next sequence of 4? 3. What is the next sequence of 5? 4. What is the next sequence of 6? 5. Next sequence of 7? 6. Next sequence of 0. But see here, up and down is set to 1. When up and down is set to 1, you have to look into the second sequence. 0. What is the next sequence of 0? 1. Next sequence of 1, 2. Next sequence of 2, 3. Next sequence of 3, 4, 5, 6, 7. Our next sequence of 7 will be 0. Then you refer to the excitation table and complete the transition diagram. So you have to look into C plus and fill DC, look into B plus and fill DB, look into A plus and fill DA. Now while simplifying you have to draw a 4 variable K map. So while simplifying you have to use a 4 variable K map. So what are the variables in the K map? So variables in the K map will be up and down CBA. So while simplifying you have to draw a 4 variable K map. And what are the values? So along the row you will have either up and down, or C along the column you will have B and A. So what are the variables along the row? UD bar C bar, UD bar C, UDC and UD bar C. Along the column B bar A, B bar A bar, B bar A, BA and BA bar will be the value. Then you have to fill the entries 0, 1, so the midterm value will be 0, 1, 2, 3 up to 16. Then you have to write the respective value DC, DB and DA, then solve it.